So welcome to the second session of the XMPP Academy. The first one was quite a great success with a lot of people joining, with a lot of good questions, with a lot of feedback. So this is something which is taking off and that you guys obviously like. So we will keep on doing this kind of event in the future. So let's start with the question we have received right now. I have prepared a few slides regarding the session you have sent me, and here's the question we will go through today. So the first question is an ejabberd question, and this is a kind of general question about ejabberd architectures. And the question about what are ejabberd backends? What are the available backends and how do they work? What are they for? How can we use them? How can we leverage them as developer building solution on top of ejabberd? So this is the first question we will deal with. And the other questions are related to XMPP more generally. So I've been asked, how do you learn? How do you experiment with XMPP? What is the proper way to get into the protocol? So this is something which I will be trying to help you with. And second question is very specific. It's specific about carbon messages, message carbons. What are carbon copies? How do they work? How do we enable them, and what are they used for? And the last question is about Merkroom and capabilities of the Merkroom. Why do avatar or why do carbons not work in Merkroom? This is something I will reply at the end of the XMPP Academy session. So the first topic is about what are backends, and to understand why we have backend in Gjabberd, you need to understand what is ejabberd about. Ejabberd is an XMPP server. And an XMPP server is about routing messages, routing XMPP packet in a stateful world. It means that routing XMPP packet is mostly stateless. Well, you have a session, but it's mostly stateless. You have users that are connected under the GID on an XMPP server, and they send messages to recipients. Those messaging are routing either to the server or to other Gjabberd ID. So basically, except the session table, which allows ejabberd to know where are each user connected in the cluster. Despite that, mostly ejabberd and XMPP is stateless. It's about taking data, putting them at another end, sending that on an XMPP TCP/IP socket, and forgetting about them. But to be able to handle all the features that are defined by XMPP, it's not only about routing, and you need states. So it's, in a sense, the basic feature of XMPP and ejabberd are stateless, but to support those features, you need also a lot of states. And in that case, ejabberd depends on data. You depend on the user base to authenticate. You depend on the contact list to populate the roster list when the user connects. You depend on the list of persistent group chat, of chat rooms when you connect so that user can join them, know they exist, so that ejabberd can know to which each room belongs to, and so on. So this part is stateful. Ejabberd rely on data, and ejabberd produce data as well. So before I mentioned that it's about routing messages between Gjabberd ID, but if you want to store the message history and to let the user browse his message history later on, or for auditing purpose or anything, you're producing data, and you're not stateless anymore. You're stateful because you have data that you need to store. So we try to make ejabberd as stateless as possible. When we deploy ejabberd, we try to be as stateless as possible, and this is the case. This is something we are pushing as far as possible in the concept we are putting together for ejabberd is software as a service, our SaaS platform. But also ejabberd need to leverage to use data, and to use those data we'll leverage backends. And that's what backends are for. It's a way to access data, to read data, or to write data. So that's it. Backends are pluggable modules. So it means you can configure them to define where you would like to store part or all of your data. So you will have, for example, a backend for authentication, and you will say my backend is my Active Directory or my LDAP directory, or it's my MySQL database. And you can select other backend for other type of needs. And the role of backend is to provide the data to the module in ejabberd that implement the features. So we have module in ejabberd that implement the authentication for XMPP authentication, but to be able to authenticate a user, you need to make sure that the password match and that the user exists and so on. So ejabberd will use backends to query the data and to make sure that everything is fine, and to be able to authorize the user and allow it to connect to the XMPP server. So I mentioned that you can read data, but you can also write data, or you can have modules that are read-only. So for example, in a typical deployment of ejabberd in the context of a social network, for example, you will not allow a user to create their own account directly through the XMPP stream. So you will not allow user to connect with a standard XMPP client and register an account. You will have another workflow for that. You will have your website, and you will have already a user base. So in that case, what you want is a read-only authentication module that will query your backend to allow authentication, but that will not populate your backend, that will not register the user on your backend. So you will have only one way to create the user, and this is on your website, typically under your own business logic. So now we know what are backends. You may want to have an overview of what are the available backends. So generally, when you have a module in ejabberd that need a backend, we support a few of them as default, and we try to respect that package. So if you want to contribute a module to ejabberd that relies on backend, you will have to provide all those modules, all those backend, if you expect to be integrated into ejabberd core system. So as a rule of thumb, we generally support the internal database, which is Nesia. Nesia is not for all deployment, but it's very popular because for a simple server, for a simple corporate server, you can just deploy ejabberd, say you use the internal database and you have no external component to deploy, external component that you will need to configure and so on. So this is very handy. It may not scale to the size of a big social network, but it's very handy for development or for a small corporate server, for example. And we also support relational database. So typically, when we provide backend, we write Nesia backend, we write relational database backend, which typically support MySQL or MariaDB, which typically support Postgres, and we try since recently to reintroduce SQL Server or Azure SQL Server to be able to deploy more easily on Microsoft Azure platform. And we support also a very small and lightweight database type, which is SQLite. So this is the kind of relational database we try to support in our backend, and we also try to support a very popular, especially in the Erlang world, a very popular NoSQL NoSQL alternative, which is React. So React from Basho team. So this is typically the kind of backend we want to support. For some other very specific modules, we try to support other backends. So for example, for authentication, people expect to be able to connect to their corporate directories. So for authentication, we support LDAP or Active Directory or Azure Directory backends. So you can plug ejabberd and let users authenticate to those backends. We try to do that also with modules like shared roster module to be able to have group inserted in your roster that match your corporate directory like marketing department and so on. So this is the case where we have additional backend. For ejabberd SaaS, we developed a full set of extra backend, which are basically calling REST API endpoint to implement HTTPS backend for user authentication, for contact list roster, for message archiving. So I mentioned that quite extensively in the first XMPP Academy. So if you are not aware about that, you can watch the previous video, which is on Process One video channel, and you can get a better idea about what is how you can integrate with your own backend using HTTP with ejabberd deployed as a SaaS platform. And of course, you can write your custom backends or use backends that are provided as contribution in ejabberd contribs GitHub repository. So for example, there is a contributing module for HTTP authentication. So this is a broad overview of the available backend. Here is configuration of backend is often not well understood. So I've tried to illustrate my talk with a few examples of how you configure a backend. So typically, to configure a relational database backend, we still use the wording ODBC, but we will introduce soon aliases to rename that to RDBMS. But basically, you define your ODBC type, which type of database you will be using. So in that case, that's MySQL, and you define all the parameters to be able to connect to your MySQL database, including, for example, the pool size. So this is something which is quite straightforward. Basically, you need to get together all your database parameters, and it will be very easy to fill that up in your ejabberd YAML config file. Then, once you have defined the parameters for your database, you can decide which module will use that. So, for authentication, it's just about setting which auth method you will be using. You will be using ODBC type, and ODBC type knows that it will be referring to your MySQL configuration that have been previously defined. So that's for the authentication, and for all other modules, it will be defined as a module configuration in the ejabberd.yaml module section. So for example, here we have a snippet. In the module section, you put the mod roster definition, and you can define your DB type and say DB type will be ODBC. So that's it. Basically, when you know how it works, it's very straightforward. It can be confusing where you're not used to that way of configuring things, but it's trust me, it's very straightforward when you get used to it. So let's try to give you the big picture. So basically, this is typical architecture for ejabberd deployment. So basically, when you deploy an ejabberd service, you deploy your cluster, you have a load balancer, you have your client connected to ejabberd through the load balancer, and you have part of the data which stays in the internal database. So for example, last seen or PubSub nodes, you may want to keep that in the internal database because it's not always heavy duty use of those modules. And for some other, like user base, contact service, message archive, you may want to use another backend. So typically, that's how you design your ejabberd architectures. And as you see, you can move to other backend as your platform grow. And and as your architecture grows and moves toward a more stateless backend. So as your ejabberd platform grows, you may want to make sure that ejabberd is very easy to manage, and make sure that you can kill an ejabberd node, restart one, and make sure that all the data will be somewhere else. So that's the kind of trade-off you have to compose and balance. So it means that ejabberd architecture really have to be designed. It's not something that you won't or you should not just deploy ejabberd, put a kind of default configuration and expect it to work fine and to scale fine and to work for any type of configuration you will be using. So you have really to think, what is my XMPP service doing? Where do I want my data? How do I avoid data duplication, and so on? So this is really something which is very important, which needs to be at the beginning, very beginning of your project, to make sure that you get your ejabberd architecture right. So here is another view of the same kind of thing I've been saying up to now. So basically, inside ejabberd code source code, you have features module, and those feature module rely on data module. This is the backend. So as you see, for example, the PubSub module, which will be responsible for broadcasting the message on PubSub nodes, which are basically channels, it will rely on a database for storing the nodes, the last item, and so on. So basically, many modules that provide feature in ejabberd rely on a data backend, and this is something that can be a bit daunting when you deploy ejabberd, but trust me, this is very flexible and allows you to really build something which exactly match your own requirement. So that's it for the big picture and the overview. So as a summary, the property of ejabberd backend means that you can build very flexible systems. Backends can be combined, so you can have can use different backend to leverage different backend property. If you have a massive amount of data, for example, for method archive, you may want to leverage Bash or React backend. If you want to target a backend for speed, you may want to store and to use a very tuned and very well configured MySQL, for example. So you really have to design your system around the property of each backend, and then you can build something which is very efficient. In most complex deployment, we don't rely on a single backend. We use a mix of very different type of backend with different properties. And backends are property based, are API based. It means that they are developed using ejabberd API, and it means that you can write your own backend, replace and register existing backend with your own to meet your very special needs. Sometimes, for PubSub, for example, we have been writing sometimes very specific backends that are everything, every node about PubSub that are hard-coded and that are in memory. It means that you don't need any database at all if you can do that, and you have totally crazy performance when you do that. So this is something which is also very important, is that you can architecture around existing backend, but you can also write your own backend to be even better and even faster. So selecting the right backend, deciding to write your own for each module is part of ejabberd solution design, and it's a very important step, and you need to take that step in your project with a lot of care. I would like to focus now on a very specific type of backend. So for now, the backend we have been talking about are backends that are used to store data that are persistent, that you want to keep, that you want to back up, that you cannot afford to lose. But there is a kind of data which is totally transient. This is the session data. In ejabberd, you have the session data that are managed by the cluster, and basically that are used to make sure when you try to reach a user, you can know where it is connected and where is TCP/IP connection on the cluster. So you may have a 10-node ejabberd cluster, you're connected on node 1 and you want to talk to a user. ejabberd will need to know, is the user online? First question. And if the user is online, on which node in the cluster is the user connected? And it will use that information to route the message that you're sending from node 1 to the node the user is actually connected on. So this is transient data in the sense that if you shut down your whole cluster, you have no data at all. You have no user connected, so you have no session, and there's no need to back up that because this is permanently changing. This is not something that you need to restore, because if you have a crash and need to shut down the cluster and recreate it, there is no purpose in restoring that data. So this is transient information, and in the ejabberd community edition, session are stored as a default in Nesia database. But we introduce a way for scalability or for convenience to select all the backend, despite the fact that this is not transient data. This is something that you may want to consult. For example, if you want to expose that on your website. So you may want to store the session data in MySQL or Postgres, for example. So be careful, because switching, for example, your session to a relational database will incur a huge performance penalty. But for small corporate server, for example, this is something that might be very handy, and you can use the information in your relational database to expose that in some way and to manipulate that in some way. So this could be a very convenient, even if less efficient. For scalability, we have ejabberd business edition clustering, which is using a different kind of backend and way to store the session data. Or you can have something like Redis, which is a way to say, okay, I don't want to replicate my session data using Nesia database, and I want just to have a single store for my session, which is a single point of failure. We all admit that, but it will avoid the cost penalty of data replication. So as you see, this is a very different type of backend. It's not for storing persistent data, but it's a way to store the data, some transient data somewhere else. So it deserved a specific mention. So now we will switch to other question, and the next one is about XMPP and how to learn XMPP the proper way, how to experiment with XMPP the proper way. And often developers get confused when dealing with XMPP because they want to develop an Android client or they want to develop an iOS client, and they start by looking at the tool that will be using to write their client to connect to XMPP. So for Android, they get to they download the Smack library and they try to play with Smack library directly. And for iOS, they download XMPP framework and try to implement that. But doing so is kind of confusing in the sense that it's abstracting the XMPP protocol and it's hiding the XMPP protocol. So what you see is how the library developers decided to encapsulate the XMPP protocol to expose it to the client of the libraries. So this is often a bad idea to start with that approach, because it will prevent you from understanding the basic of XMPP. What is XMPP about? How does it work? What you need to be familiar with when you learn XMPP is the RFC defining XMPP, This is something very fundamental, and those RFCs do not talk about the library, they talk about the XMPP protocol itself, what goes on the wire, and you need to understand that. And the good part of XMPP is that if XMPP is text-based in XML and so on, it's because it's readable and it's usable from a console, for example. So what I recommend is to learn XMPP at the XMPP packet text protocol level. And for that, I'm often showing that you can use the Psi client, which has a very good XMPP console that you can use to check the traffic, see what the client is sending, see what the client is receiving, and learn the XMPP protocol with that. So you can see, okay, when I log in, here is what the client is sending. When I'm joining a mock chat room, here is what the client is sending, and here is what I receive. And it helps you learn how the XMPP protocol works. It's also very handy to troubleshoot your own client. You may chat with a standard client and compare with your own client behavior. And when doing that, when comparing, you need to make sure that your own client, when you develop, is able to dump traffic at the XMPP level, because if you need to troubleshoot your client, you need to know, is the issue I am chasing something which is a problem in the server, something which is the problem in my client, in the way I am using the library, or is it a bug in the library itself? Or did the protocol change and my library should be updated to support a new extension and so on? So this is something you need to get familiar with. And with the Psi XMPP console, what is very nice is that there is a way to send, to authenticate, and then to plug directly in the XMPP stream and send your own packet. You can send a packet and see what the server reply, and you can experiment with that. This is very handy, and this is something I will show you in the next, not the next slide, but after I've talked a bit about the message carbons. So let's transition to the message carbon question. And what are message carbon about, and how do they work? So message carbon are defined in XCP 280, and this is a feature that is intended to make sure that all connected clients using the same Gjabberd ID. So if you connect several times using your own Gjabberd ID to the XMPP server, you will have several sessions open at the same time. And in standard XMPP, if I send a message to one of my contacts, the other client won't know that. So it may be confusing if you're looking at or switching from one client to another. It means that the state of your conversation will be different depending on where you have been chatting at a given time. So if you want to receive all the message and to synchronize all the message you have been sending in your online client, or if you want to synchronize all the message you have been receiving in your online client, you need to use message carbon and to enable message carbons. So this is a very, very simple protocol that is supported by ejabberd, and that will have the server, once you have enabled the feature with an IQ to explicitly enable carbons for a given session. Once you enable that, you will receive copy of your own message, no matter which session they are coming from. And you will receive copy of incoming message, no matter which connected client has the highest priority. So, the client with the highest priority will still be the primary recipient for the main message, but the other client will receive copy of them, and they will be marked as copy, so it will be forwarded message basically. So what I plan to do is to join the two questions, the one about learning about XMPP and the one about Carbon, to show how to understand Carbon by playing with Carbon with the Psi XMPP console. So here is a demo I have recorded to be more free to describe it. So basically, in that I've set up Psi to have 3 accounts connected and defined. And the first thing you have a demo 1 client, which is demo 1A, which is connected with the resource Psi 1. So I have opened a chat window here with the demo 2 user. You have demo 1B client, which is connected to the XMPP server with another resource. So this is a second connection for the same demo 1 user. And you have a single demo 2 user. So here, the demo 2 at the bottom, you see demo 2 speaking to demo 1 user. And you see that, yes, basically both demo 1 user at the top window is receiving the message from demo 2, and demo 2 at the bottom is receiving and sending message to demo 1. In the middle, I've opened a console, XML console, for the second session for the demo 1 user, so the Psi 2 resource. And as you see, I'm chatting with from demo 1 to demo 2 user and back and forth. And as you see, the second session connected does not receive anything. So the second connected session doesn't know about the fact that I'm already chatting from another connected client. So here what I'm doing is that excuse me, I've been sending the XMPP packet to enable the Carbon message for the second the Psi 2 connected resource for the demo 1 users. And as you see, I received the IQ so I copy paste the IQ I want to set, and I received an IQ confirming that the user has properly enabled for that session Carbon messages. Then I will be sending message from the demo 1 users, and as you see, I'm starting to receive copies of the traffic. So as you see, this is messages that are clearly shown as forwarded, so you cannot confuse them with normal messages. So you see that you receive, now my other resource receives the Carbon, and this is received by, this is a copy of the message you have sent, received by your second connection. And when the user 2 replies, demo 2 replies, you will see that you will also receive a copy. So the primary message is received by the first Psi 1 session, but the second resource, Psi 2, will also receive a copy of that message. So as you see, this is really, really handy, and in a few minutes, you can read the XMPP extension proposal, understand what it's about, and start playing with it directly on the server. So you authenticate, you set up your account, and then once you're authenticated, you have a playground to experiment with XMPP, which is really something you really want to do, because this is fun, and this is what brings the fun into XMPP. Experiment with that, and we see that you will like XMPP a lot. So the last question I've received is, I sometimes receive question about why do these features, so in that case it was avatars, does not work in Milkroom. I don't see avatar of the people that have joined the room. Or what do Carbon not work directly in Milkroom? And what you have to remember is that one-to-one chat in XMPP is very different from the multi-user chat. Multi-user chat is a proxy. This is something that allows you to discuss with other users with your message going through a proxy, and multi-user chat is designed as a way to be a proxy, that is to make your messages semi-anonymous, basically. So if you're not admin, the default behavior will be that you won't be able to see what is the real GID, Gjabberd ID, of the user that is speaking in the chat room. And in most of the case, to be able to get the avatar through, for example, vCard retrieval, you need to know the GID, the real GID of the user that is speaking in the chat room. And you don't know it because it gets through a proxy. So Mushroom are on purpose and by design limiting some of the features of XMPP for privacy reasons. It means that avatars are intended to be used by your contact. This is for people in your contact list. And in that way, you make sure that the avatar that you're sharing is not seen by unintended people, only people that you have accepted in your contact list. And even if your client does not use vCard avatars, but PEP avatars. PEP avatars are roster-based, so you need to be in each other roster to be able to use PEP and to get broadcast about the PEP event. So you need that to be able to retrieve the avatar and update the avatar and so on. So if you do not see avatars in Mushroom, this is by design. This is how Mushrooms works in XMPP. And of course you have solution to do that, but you have to work around. If you want to have anyone see anyone avatars, you have to configure your server differently for that purpose, or you have to use custom modules, or you have to do something on purpose to say, okay, I want this privacy feature of XMPP to work differently or to be disabled and so on. So this is something you have to do. And for message Gjabberd, for example, if you read XCP 280, you will see that it explicitly excludes nuke messages from the scope of the carbon messages. Because nuke messages, you are not supposed to join a nuke room several times with the same GID. And even if you can do so with new iterations that have been added to the multi-user chat specification, this is not something that that you need, because if you're connected twice in the room, basically you're like a normal user, and the MOOC room will broadcast your message as for any other user. You're connected twice in the room, and this is the proxy, so you see the message. All messages are broadcasted properly. So you don't need carbons in the case of MOOC. What you need is that if you want to get a copy, to get message that you send from one resource in the MOOC room to another connected resource, you need to have both resources join that MOOC room. So this is the thing you need to do to receive the message live. So I hope to have clarified the spatial status of MOOC compared to one-to-one chat. This is different protocol, so you cannot expect them to behave totally the same. So this will end this XMPP Academy session. This is the second one. I hope you have enjoyed it. Thank you for having sent me all your questions, and I'm ready to receive new questions for the next XMPP Academy. So I expect the next XMPP Academy will be sometime in December. We will post the final target date on the Process One blog. So yes, keep the question going. Post comment on YouTube on the video, like the video if you have found it very very helpful for building your XMPP systems. And yes, see you next time. Thank you guys.